Hi, hello, welcome to Unit 7. We're going to be starting this term 4 off. We're going to talk about trigonometric ratios. I love this part of trig. I think it's very basic, it's pretty cool, and can get useful the more you delve into it. So let's get started. So during this lesson, you're going to learn how to understand the relationship of angles and the sides of a right angle, and be able to use trigonometric ratios to find the missing side of a right triangle. Some vocabulary: similar triangles are all corresponding pairs of angles that are equal, and all corresponding pairs of sides are proportional between the two triangles. So we have angles are equal and sides are proportional. So we have equal and proportional there. A ratio is the relative size between two values with sizes a and b. Ratios can be represented as a to b or in fraction form is a over b. A right triangle is a triangle with one right angle. Can't have two or else it wouldn't be a triangle. A reciprocal is when the numerator and denominator are switched. Okay, let's talk about some right triangle trigonometry. So right triangles are unique. They have some cool ratios that happen. Right triangles contain one angle that is measured at 90 degrees. Oftentimes you'll see this symbol that signifies a right angle. When defining sides of the triangle, remember that the hypotenuse is always opposite the 90-degree angle. Angle measurement correlates to side length. So what that means is any angle, if I have the biggest angle in the triangle, it's always going to be directly across from the opposite side, or from the biggest side of the triangle. So let's erase some of this. So what we can see here is that my 90 degrees is always going to be my biggest angle, which means this hypotenuse is always going to be the biggest side. Okay. The other sides that we think about is if this is the angle I'm looking at, we're going to call this theta. Okay, it's a Greek letter. It gets used in math in place of like x when we're talking about angles. So it's an unknown angle. You'll typically see it be theta. If we're looking at this angle, I have my hypotenuse, my longest side, right? And we have the side opposite, very specific, right? Just directly across, and adjacent being next to. So my adjacent side always creates the angle I'm looking at with the hypotenuse. Now this can change based on if I'm looking at a different angle. Alright. So there are 6 trigonometric functions we're going to talk about, okay? So the ratio of sides is equal to trigonometric functions of the acute, which is a non-right angle of the triangle. The 3 most common trigonometric functions are sine, cosine, and tangent, okay? And I told you there were 6, so there's 3 more. We'll talk about those in a little bit. So trigonometric ratios. So I would say the first one is sine of theta equals the opposite side divided by the hypotenuse. All of these ratios, or all of these functions, I'd say, like sine of theta, is going to equal a ratio, opposite side over the hypotenuse. The cosine of theta equals the adjacent side over the hypotenuse, and the tangent of theta is equal to the opposite side over the adjacent side. I'll show you what we mean here. So you can remember the 3 main trigonometric ratios with the acronym SOHCAHTOA. Okay, sine. So we have like our sine is our opposite over the hypotenuse. Cosine is adjacent over the hypotenuse. Tangent is opposite over the adjacent. Okay, here's the other 3. We have the trigonometric reciprocals. Remember, reciprocal just means my numerator and denominator change places. So the reciprocals of these trigonometric ratios are also defined as the cosecant, which is the reciprocal of sine. The secant is the reciprocal of cosine, and the cotangent, which is the reciprocal of tangent. The trick here is remembering where cosecant and secant, what they are reciprocals of. I remember this as c and s cannot go together, so I have a c and an s. Cosecant with sine, secant with cosine, and cotangent with tangent. Okay, so primarily those two. Cotangent and tangent are easy to know, they go together. The cosecant and secant can get mixed up a little bit. Alright, so I'm going to show you how I would find these ratios. So using trigonometric ratios, we need to find the 6 different ratios for each of these sine or these trig functions. This is what I like to do first. Is I say, all right, here's my angle right here. Okay, so we're looking at this. I'm going to just label each of my sides. So I have my hypotenuse. I have my side adjacent, because my side adjacent and the hypotenuse are going to create my angle. And then I have my side opposite, okay? I'm going to go, okay, I have so, ka, toa. Okay, so we're going to start with sine. Sine is the opposite side over the hypotenuse. Okay, my opposite is 3, and my hypotenuse is 5. Then ka, which is adjacent over hypotenuse, so my adjacent side is 4. My hypotenuse is 5. Tangent, toa, tangent is opposite over adjacent, so 3 over 4. And these next 3 are just the reciprocals of the first 3. So cosecant, so sine, and so cosecant goes with sine. My c and s have to go together. So I'm going to just take the sine and say 5 over 3. We just flip it. Secant goes with cosine, so we flip that one, 5 over 4. And cotangent goes with tangent, 4 over 3. I just did my reciprocals. Okay. All right. There they are. We did them. We got them right. All right. So now I want you to try. So it says find the trigonometric ratios. Try on your own, and then we'll go over it. Okay. So what we're going to do is first, these all say sine of 60. So that's the angle that we're talking about. So here's my 60 degrees. I'm going to identify my different sides. So in this case, my hypotenuse always stays the same. But now that this is 60 degrees, my opposite and adjacent are going to change. So I know that this has to be my side adjacent because it helps make my angle with the hypotenuse. And this is now my side opposite of 60. Okay, so the sine of 60 is so opposite over hypotenuse, so the square root of 3 over 2. The cosine of 60, so ka, would be adjacent, ah, 1 over 2. And the tangent of 60, so toa, is opposite over adjacent. We have the square root of 30 over 1. Boom, we got it. All right, let's try. So it says find the missing side. So we can use the Pythagorean theorem if we're given 2 sides and we don't have an angle. So it says find the sine of x. Well, sine, I need so opposite over hypotenuse. So I have my opposite, but I only have my h. So we have to try and find this. So all right, we know that the Pythagorean theorem is a squared plus b squared equals c squared, which is a and b are my 2 shorter sides, which is the things we have. So I'm going to say 6 squared plus 8 squared equals h squared. In this case, I'm just substituting the numbers and symbols that I have. So I have 36 plus 64 equals h squared. 36 plus 64 is 100. We take the square root, we know h is 10. Well, it's plus or minus 10, but we know that it has to be positive because we're talking about length. So we know that the sine of x equals 8 over 10. We don't have to simplify it. All right, that's all for this first lesson. If you have any questions, please feel free to come talk to myself or a tutor. We'd be happy to help you. Have a great day, and we'll talk to you later.